Newton's laws of motion. Look at the girls on the slide. Many different forces are acting on the girls. The water is pushing them down the slide. Gravity is pulling them down the slide. These forces are unbalanced forces. Unbalanced forces are not equal. The forces that are moving the girls down the slide are greater than the forces that are holding them up. Because of these unbalanced forces, the girls slide down into the pool. Sometimes different forces cancel each other out. Suppose you and your friend are both pulling on a book. You notice that even though you and your friend are pulling really hard, the book doesn't really seem to change position. This is because the forces that you and your friend are applying to the book are the same and cancel each other out. These forces are now balanced or equal. Unlike the unbalanced forces that are pulling the girls down the slide, the forces that you and your friend are exerting on the book are balanced, and so the book does not move. Newton's first law. Any object that is not moving is said to be at rest. Many of the cans in the photo are at rest. According to Newton's first law, an object will stay at rest unless acted on by a greater force. In other words, something that is not moving will not start moving until it is pushed or pulled. When the cans are hit by the ball or other falling cans, they will move. The law also states that an object will continue in the direction and at the speed that it is moving unless acted on by a greater force. After the ball hits the cans, it may hit a wall and then stop. The wall exerts a greater force on the ball than the ball exerts on the wall, and so the ball stops moving. These cans will stay at rest unless they are acted upon by a greater force, such as the moving ball. Newton's second law. Look at the photos on these pages. Which person is using more force? How can you tell? You know that Newton's first law of motion tells you that a push or a pull can change the motion of an object. His second law of motion tells you that a harder push or pull will cause a greater change in the object's motion. It also tells you that an object with more mass is harder to move than an object with less mass. In the first photo, the big splash shows a greater change in the water's motion. It shows a person using a lot of force to make a large amount of water move quickly into the air. The small splash in the second photo shows less force being used. Another important part of Newton's second law is that the speed at which an object moves depends on the mass of an object and the size of the force acting on it. Suppose you were throwing a baseball. The force you exert, or the speed at which you move your arm, affects the speed at which the baseball moves. However, if you tried to throw a bowling ball, you would need to use a lot more force than when throwing the baseball. As the object's mass increases, so does the amount of force needed to move the object at the same speed. Since the bowling ball has more mass than the baseball, it is harder to throw at the same speed. A small splash shows that less force is being used because a smaller amount of water is being moved. Newton's third law. Look at the photo below. How does the woman get the kayak to move? Newton's third law of motion helps explain how she does it. When she paddles the kayak, she pushes the paddle against the water. The water pushes back against the paddle. The two forces exert in opposite directions. The result of the forces is that the kayak moves forward. Newton's third law of motion is often summarized as, for every action, there is an equal and opposite reaction. When the woman forces the paddle through the water, which is her action, the water pushes back against the paddle with an equal and opposite reaction, and off she goes. Sometimes the equal and opposite forces cause no change in motion. For example, the people that are sitting at the beach are exerting force on their chairs. The chairs are exerting an equal and opposite force on the people. The result of these forces is that the people are seated in their chairs and do not fall down. The forces being applied are balanced. When you are sitting, you push down on the chair. The chair pushes up on you. Science in a snap. Balloon rocket. Blow up a balloon. Tape a straw on top of the balloon while you hold the end of the balloon. Thread a string through the straw. One partner holds each end of the string. Move the balloon to one end of the string. Let go of the balloon. What happened to the balloon? How does the third law of motion explain what you observed? Before you move on. 1. What are balanced and unbalanced forces? 2. Why is it easy to push a toy truck, but hard to push a real truck? 3. Apply. How does a bed exert force on you while you are lying in it?